Okay, so this is like a finale for all the Newton's law of things that we have been doing. Okay, kind of the first thing that you will need to remember are things like inclined plane. Okay, so you're gonna have to remember how to break them into the different parts, what forces goes with what, and what's on an angle and things like that. That's the first one. We will review this in the next slide. Second thing is we are now mixing that there is a possible pulley situation. So we could be on an inclined plane, but we now hook it up to whatever. Sometimes the pulley can be straightforward like this. Sometimes it could be a slant with a slant. Okay? So what that means is you're going to have to remember with these types of questions, you're going to remember that when it's the same rope, force of tensions are the same. When they're tied together, the acceleration are the same, and you come up with ways that make sense. Is it up this way, up that way? And also, you're gonna have to also remember that this is two object, right? Object one, object two, and you're gonna do two blocks, and you're gonna separate them out, and you draw your free body diagram for each of them. Then you would do your XY forces for each of them if needed. Okay. Now the third thing that we're gonna also tie in is now there is also friction, possible friction. Okay, and friction goes against the motion, right? So if I have an incline, and if the block, it depends on which way it's sliding. If the block is sliding this way, my force of tangent is going, I lied, but force of friction is going to be opposite to that. But don't forget, your gravity and force of normal are not the same, and we will talk about this in detail again, right? So you're going to have to do your along x, along y, and then we're going to break them into components and all those stuff, right? So that's like tying it all together. The third law, the second law, the friction and everything. So you are also going to have to require to use this equation, and you would figure out the Fn along the y directions, right? So these are all the things, and then we tie them all together and form these lovely inclined plane pressure questions. So similar to like the skiing questions that we did in like 3 lessons ago, we would do something on an incline, and we always would have an angle. We would always have an angle this way, and keep in mind that that angle is the same angle that goes with the FG. We always have the FG going downwards, going straight down, and we would always have one that is perpendicular to the surface. Okay, and if there's any pulleys or strength, it will be always going to be along the string with force of tension. And one more thing is to keep in mind that we always keep the x and y direction along how it's sliding. You see how your acceleration is either that way or the other way, but it's always going to be along the slope, right? Like I'm dragging this box along the an incline or something like that, right? And so what that means is if my FG is here, you're going to have to break FG. FG is the one that you always have to put in components whenever we're dealing with inclined plane question. Inclined plane means the object is sliding up and down the slope, right? Okay, so this is Fn. And so to break FG into component, I'm going to kind of line it with Fn, and I'm going to draw a straight line down until it line up with the FG, and it's going to go this way. If this is angle theta, this is angle theta. They're always going to be the same. And if this is the theta, this is FG cosine of theta, and this is FG sine of theta. So the XY component of what FG is. Okay, so it tells you a skier has just begun descending at a 30-degree slope. Assuming mu k is 0.1, so there is a force of friction. Calculate her acceleration and the speed when she reaches after 4 seconds. So two-part question, they find acceleration and then use that for kinematics. Okay, so draw your slope. Tells you it's a 30-degree slope, so I'm going to draw a straight line. Ooh. And it has a slope of 30 degrees. And this here is a box. And the box has force of gravity going downward. This is Fg. And it's sitting on the surface, perpendicular to the surface is Fn. And it's telling you it's going downhill this way. So the acceleration is coming that way, meaning the force of friction has to be moving to the uphill. They want you to find acceleration. So I know this is tilted, but I still ask the same question. If there's anything that is not lined up with the x and y, so it's almost like you can think about the x and y axes now tilted. So anything that is not along the x and y axes like that, we have to break them into axes. So this is the guy that is not lining up with the x and y. So I'm going to have to break them into component. Okay, so I'm going to break my FG into x and y component. This angle is 30. And this is FG sine of 30 because that is opposite to the angle. And this is FG cos of 30. Okay, then now I'm going to sum up my forces along x and along y. So I would do almost the same thing. It's almost like you're tilting your paper kind of on an angle. Okay, so what is the net force along x? So let's summarize that. I'm going to use a small blue one. I have two forces along x. I think most of you see this. That's a backwards. That's along x. But I also have this. Okay, I have two. Which way is forward? Forward is down the slope. That's forward. So I would go down the slope minus up the slope. So down, so FG sine of 30 minus FF equals to MA. And this time the acceleration I cannot cancel. To figure out FF, I need the Y. So I'm going to now work on the Y. Okay, Y, how many forces do I have? I have one that's going up and one that's going down. So two forces along Y. So up minus down. Now this time the down is component of the FG and is equals to MA. Is there an alarm ringing? Are you asking what I would always ask? What am I going to ask next? Say it. What am I going to ask next? I hope you're asking yourself, what is the acceleration along y? And I hope that you're like, oh, it's 0, it's gone, because I'm not going along the y directions at all. So Fn is equals to mg cos of 30. I don't have mass, but I have everything else. G cos of 30. Okay, so I'm going to sub this into the FF equation. So what is FF? I know the equation for FF is mu Fn, so I'm just going to write this out. Okay, so mu times Fn, which is m 9.8 times cos of 30. I'm not going to multiply it out right now. I'm just going to write in my number, sorry. So m 9.8 times cos 30. So I'm multiplying this into the Fn. Alright, it looks really big. It looks ugly, but we're going to move on. I know mu is 0.1 times m 9.8 cos of 30. If you want to multiply it out, you're welcome to do that. Why don't we just do that? 0.1 times 9.8 times cos of 30. So all these stuff worked out to be 0.849 m. That's what FF is. I don't have m, so I can't cancel them. It's still there. Okay, now going back to the x equation, because now I have FF, so I'm going to start subbing this in. And I know that this is mg. Fg is mg sine of 30 minus FF. I'm going to sub it in the 849 m equals MA. Oh, next thing you can do, hopefully you're seeing that, M is in every single term. You see the M, and M, they're in every single term. When I have something that in every single term, I actually can cancel that. Okay, so I'm left with G sine 30 minus, whatever equals to A. So let's rewrite that. I'm just going to rewrite that. So G is 9.8 sine of 30 minus 0.849. I don't have the M anymore, equals to A. See how I can just punch it straight into the calculator and get an answer? So 9.8 times sine of 30 minus whatever answer I got. So I found A to be 4.05 something. So 4.1 meters per second square forward, 30 degrees down. Okay, so that's part A. Well, it did ask for calculations. Part B now asks what is the speed. So I'm going to redo my given list because I didn't write them out. It just began to move, so V1 is 0. I found my acceleration to be 4.1. And I know that I would like to find V2 after 4 seconds. That is my time. So find my high five, V1A, V2, and T. So which one of these equations only has these 4 but nothing else? So it's the first equation. V2 equals V1 plus A delta T. Okay, so V2 is what I'm looking for. So 0 plus A times T. We'll times that by 4. So V2 work out to be 16 meters per second. So after 4 seconds, forward 30 degrees down is what the velocity is for V2. Okay, so now they've slightly changed the question. It is still moving down a 30, but this time traveling at a constant speed, and they wanted to find the kinetic coefficient of kinetic friction. Draw your picture. So the question is almost the same. Okay, so I'm just gonna redraw my picture. So I just want you to get used to it. I know the questions are repetitive, but you need to get used to how to draw your FG and FN and which way is moving. So I'm still going to keep my axes going X, Y like that. But this time I'm going to write in A is 0 because it's telling me it's going at a constant speed. I still have force of friction because that's what I'm looking for. Anything that's not lined up with X and Y, break them into component. Okay, this is angle theta, which is 30. This is FG sine. And this is FG cos. Once you've been through a couple of times for these types of questions, it's repetitive and it's the same thing over and over again. Okay, so study your forces along X, study your forces along Y. And this time acceleration is 0, so meaning both X and Y, F net equals to 0. Along X, two forces, FG sine 30 and FF. So that's along X. So downhill, FG sine 30 minus uphill, which is the FF, equals to MA, and this is 0. And so I know that MG sine 30 is going to equals to FF on the other side, and I know that FF is mu FN. So I'm just going to expand everything out as much as I could. That's as far as I. Then let's figure out the Y along the Y direction. So how many forces are going along Y? So let's change color. So I got Fn going up, Fg cos theta going down. So up minus down, up minus down. And it's equals to MA. A is 0, right? No acceleration along Y. So Fn is Fg cos theta. Now take this and sub it into the Fn, and we will see that it's mg sine 30 equals mu mg cos 30. M and M separate with each other, so mu, bring the g cos 30 to the other side. So g sine 30 over g cos 30. G and G also cancel. So sine 30 over cos 30. If you want to go tan 30, you're allowed to. And the answer, coefficient of kinetic friction, worked out to be 0.58. Oop, no degree, sorry, no units. Okay, this last question is kind of like grouping it all together. Do you see pulleys? Do you see a slope? And do you see a mu k, meaning it has a force of friction as well? So we're grouping it all together, all the fun stuff. Split the question up into block 1 and 2. Okay, so I'm going to call this block 1, and I'm going to call the other one block 2. And you go a step at a time. The rule hasn't changed. Okay, so I'm going to go block 1. I'm going to go block 2. I'm going to write out the direction of acceleration. 15 and 10. I'm going to say that this is going this way and it's going to go this way. Okay, at an angle of 25. So block 1. Oh, let's change the color. Let's use blue. Just keep it color coded. It's good to have your thing nice and organized. So M1 is 10 kilogram. Okay, I'm going to ask you to assume 2 sig dig in this question. M1 is 10 kilogram. It is on an incline. And with the block, meaning going downwards, this angle is 25. This is FG going downwards. At the same time, you have FN. And it has a rope that is pulling it up. Whenever it has a rope, it says it has an FT. And if it's going upwards, force of friction will be going this way. If you have it going the other way, your force of friction should be on the other side. And I'm going to fill in my acceleration direction. Yes, I want red. Okay, I'm going to say that is going this way. Okay, analyze the force along X. Now this is like everything all together, right? So do you notice anything else you need to do? FG. FG on an incline, you break them into components. Okay, so going down and going backwards. So FG sine of 25, and this is FG cos of 25. All right, sum up all the forces along X and Y. So along X, the X direction, we didn't draw this down, it's going X and Y. So forward going up, I have 1, 2, 3. Do you see 3 forces that are going along the x-axis? Remember, your x-axis lined up with your incline, right? So my X, I have a forward, I have a backwards, and I have another backwards. Ooh, this is horrible. Okay, so I have 3 forces that are going backwards. Let's change the color. You can't see anything. Okay, so 1, 2, and 3. These are my X. Okay, forward minus backwards equals MA. Okay, sub in what I know. FT minus mu Fn minus mg sine of 25 equals MA. Okay, I don't have Fn, and hopefully you're by this point knowing that every time when it involves friction, I always have to calculate the y direction. So I'm just going to do the y direction up here at the side. We're still doing block 1. Okay, the y direction, so how many things that are on the y direction? So I have one that's going upwards, and I have one that's going downwards. So I have 2 forces. So going up is Fn, going down is Fg cos 25. And it equals to MA, and it equals to 0. Okay, I'm not accelerating along Y. The only time you would have something accelerating along the Y is when the block is being hanged there, so meaning M2. Okay, so Fn is equals to mg cos 25. So you want to sub it in, work out the answer, you're welcome to. So mg cos 25, so I sub in my mass being 10. Being organized is good, remember we talked about that. So this worked out to be 88.8, something like that. And now I can sub that into my Fn. So now I'm going to start throwing in numbers that I know. So Fn minus mu 0.2. Fn is 88.8 minus m, which is 10, times g sine of 25 equals to ma. So I just plug in everything I know. I still, just like all those pulleys question, I do not know A, I do not know FT. So now I'm just going to punch it all in. Like, these is just a number that I can punch it in the calculator, right? So 88.8 is what was in my calculator, and I'm going to punch them all in, okay? So FT minus 59.18 equals to 10A. So this is what I got so far. That's one block, and that's all I'm going to be doing right now. Now I'm going to repeat the process, but now for block 2. So block 2, I'm going to write down M2 is 15 kilogram. I'm going to draw my free body diagram, right? Because it's hanging there, I have an Ft going upwards. There's always force of gravity going down, and the object is traveling downwards. So my Fnet equation is down, which is Fg, minus up, which is Ft, equals to Ma. Fg means m times g, minus Ft equals to Ma. Throw in the number that I know. I know m is 15, g is 9.8, minus Ft equals m, which is 15, times A. So throw those into the calculator. So 15 times 9.8 is 147. So 147 minus Ft equals to 15A. So you now have two equations with two unknowns. So sub one into another. So I thought that an easy way is to get this Ft on its own and then sub it into the other one. So I'm going to bring my 59 over. So it becomes 10A adding 59.18. And then I'm going to do substitution and put it into this Ft. Okay? So 147 minus whatever Ft is from the other equation. Be careful, this is a minus. I'm purposely putting it in a bracket in a different color just so you know where they came from, because I have a minus. You have to expand it out and be careful of the sign. Equals to 15A. So the minus goes into both of the terms. So this becomes 147 minus 10A minus 59.18 equals 15A. Collect your like terms. Bring your A to one side, and my numbers are all on one side already, so I know that I need to bring this over. It used to be minus, so it becomes a plus. So I take my 147 minus 59.18 is equals to 15A adding 10A. So 147 minus whatever that number. So 87.8 is equals to 25A. So now divide that by 25. My A worked out to be 3.5 meters per second square. So I found that. It says find the acceleration of the blocks, right? So it doesn't say which one. I don't put the direction because it could be up the slope or down the hill. So finally finishing it up, I need to find out what is the force of tangent. So tangent, find one of the tangent equations. So I like this one. So I'm going to just rewrite this. So I know that Ft is 10A plus 59.18. So 10 times A adding 59.18. So force of tension, I got 94.